Hi guys, welcome to my YouTube channel. My name is Ibrahim Suleiman. Today I'm going to teach you a 48 volt inverter installation. I'm going to be using a 3320 watts panel, 10 in number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, and each of this panel has a MPV of 34.2 volt. It has a open cycle voltage of 40.8 volt. It has current, maximum current of 9.37 amp and short circuit current of 10.18 amp. Yes, so I'm going to be using 10 of this panel to do my 48 volt installation. So I'm going to be doing a series and parallel connection to ensure I get maximum voltage and maximum amp, that is the current. So I'm going to do the 10 panels 2 2 2 in series. So if I do 2 2 in series, I'm going to be having 5 sets. I'm going to be having 5 sets. 1 2 3 4 5. So at each of the sets is now going, if I do series, each of the set is going to give me 81.6 volt. 81.6 what volt is going to give me 81.6 volt. Yes, as you can see, I decided to use the open circuit voltage, which is 40.8. That's what I use. I use 40.8 volt, and that's why the series is giving me 81.6 volt. Then in the power, in the maximum power, I decided to use 9. In the power, I decided to use the maximum power, which is 9.37 amp. So now I'm having a set of 5 320 watts panel, 2 in series to give me 5 sets. Okay, so now this is the final output that this solar array is going to give me. This solar array, this is the final output. So I'm having a total voltage of 81.6 volt. I'm having a total voltage of 81.6 volt, and I'm having a total amp, that's the current, of 46.85 amp. Because if I do as I did series connection, my voltage doubles while my amps remain the same. So now I have 5 sets. So 5 times 9.37 amp is going to give me 46.85 amp. So that is how I designed my solar array to give me the maximum voltage I will need, and then to give me also a good amp to charge my battery bank. Okay, so what you do after then is you are going to get your cable starting from the beginning of the first panel to the end of the last panel. You are going to have 2 cables, the positive line and then the negative line. So you are not going to do parallel. You will parallel all the 5 sets together. So when you do the parallel, you know what it means. You are going to hook up all the positive of each set to the positive line of the cable, and you are going to link up all the negative line of the sets to the negative line of the negative cable. Exactly. What I'm saying is that you are going to do all the positive, you merge them together, then all the negative of the sets, of the 5 sets, you merge them together. That is what we call the parallel connection. You can see now we did series and then we now did parallel. So when we did that, we got 1.6 volt total volt. Then we now got a total arm of 46.85 arm. So now we'll come down to our charge controller. This is a very sensitive aspect. I will always advise you use a MPPT charge controller because it regulates your current and it gives you it is 99.9 efficient. So if you use MPPT charge controller, it's going to regulate your battery very well and there will be no loss from the solar array. Okay, now I've gotten this is what I will use to determine the type of charge controller I'm going to use. So for me, I will decide to pick a charge controller with a maximum power voltage of 150 volt and also a current of a maximum current of 60 amp. This will match my solar array. So as expected, the charge controller has the slot, 3 slot. It has the slot for the panel, as you can see. It has the slot for the battery and it has the load slot. So now you're gonna take the positive line, which is this from here, take it this way like this and bring it to the positive side of the charge controller. But before then, you have to hold on. You don't hook up the panel first. The first thing you have to do is to hook up your battery. So these are my battery banks. These are my battery bank. So I have 200 amp battery, 12 volt, 4. So I'm going to do series to get my 48 volt current. So now I have a 48 volt bank, 48 volt bank with a total of arm of 200 amp. Okay, so now this is my battery bank capacity. So now in any installation, you make sure you hook up your battery first to the charge controller before you now connect your solar array. This will avoid damage, because if you first put the panel, the current may blow off the charge controller. But the ideal standard is for you to connect your battery first. Exactly. Okay, so now I'm going to do series to my battery to get 48 volt. When I pick the negative from the first battery to the positive of the second battery, I'll pick the negative of the second battery to the positive of the third battery. Then that's how I'm going to do from the third battery negative to the positive of the last battery. So I'll be left with the negative side here and the positive side here. So this is the positive terminal and this is the negative terminal. So I'm going to hook up this positive terminal to the slot, to the positive slot on the charge controller of the battery. I'm going to tighten it very well. Make sure you tighten it very well to avoid partial contact. Then I'm also going to take the negative from the negative terminal of my battery bank to the battery slot, the negative side of the battery slot, as you can see in the diagram. So by the time I do this, my system is going to display the battery bank I have, which is a 48 point something volt, depending on the state of charge of the battery. So when I'm through, I will now connect my solar cables from the solar array, and you're going to see it immediately I connect it. You are going to see a display of the sun like this, then with a panel like this. going to see something like this. So that means it has started. So as I was saying, as immediately you connect the positive and negative terminals of the solar array, the cable is going to display the sun and the panel, and an arrow to indicate that it has started charging. Then this number is going to boost. It can rise to as up to 49 point something based on the rate of voltage that is coming in at that time. So I told you my charge controller is rated 12/24/36. That means it can use a 12-volt battery bank, 24-volt battery bank, 36-volt battery bank, and 48-volt battery bank. So I'm using the 48-volt battery bank. So my battery bank is 200 amp, then 12 volt into 4, that's 48 volt. So after doing this connection, I'm almost done. Then the next thing is to take my inverter. My inverter is a 48 volt inverter. It's a 48 volt inverter, 5 kVA. 48 volt inverter, 5 kVA. So now if I want to connect my inverter now, I'm going to take my positive terminal of the inverter or the cable and connect it to the positive terminal of my battery bank. Same, I'm going to take the negative cable from my inverter and connect it to the negative terminal of my battery bank. Immediately I do that, then the inverter is going to on. So if the inverter ons, then I'm now going to have what? I'm now going to have an output. I'm going to have an output. So that output is an AC output, because the inverter does the work of converting the DC current, the DC in the battery, to alternating current. So this is a complete installation, a 48 volt installation, 5 kVA, 5 kVA installation. So this is capable of powering your home accessories such as 2 TVs, LED, 1 fridge, then 4 fans. Can also power your bulbs, let's say 10 bulbs, 6 blender, your phone, your 7 laptops, 8 phones. It's going to give you a 24 hours, 7 days a week, non-stop. So this is a complete solar installation on 48 volt 5 kVA installation. So when you get to this point, you are having the your output is now ready. You have to connect it to the house so that the whole house is going to have a light to all these points. The television, the fridge, the fans, the 10 bulbs, the blender, the laptop, and the phones. All the lighting point, all the sockets. So sockets. 3, 4, 5, 6, 7. So now you are going to now you have your output. So what you do now is to go to your DB board, you go to your DB board. Right here by the side of the inverter, you are going to have your two sockets. You are going to have your two sockets. One will be for input and then one will be for output. One will be for input and one will be for output. So what you do now, you just go to the DB board, your DB board, DB. So you are going to separate from the stop lock. You have stop locks here. So you are going to remove all the ones that goes to all those appliances that you have mentioned. You are going to remove all of them like this. Then you are going to tie them together. You are going to tie them together. So when you tie them together, you will now take it through the ceiling. This is the positive. Then the neutral used to be here. You are going to attach the neutral wire. Then this wire and the wire you have bundled here, this wire will now come directly to your output. To your output here. This is the neutral. This is the neutral line. Neutral. So this is the neutral wire. It's coming like this. It's going to come to the output socket. So if you now connect your output from the inverter to this output socket, then you are going to have light in those points I've mentioned. So also from this DB board here, you are going to pick any star block that is empty. So you pick it for the charging, for the input. So you will now pick it, pass through the ceiling, take the positive, then the neutral, you tap, you put your neutral also in the neutral line, you bring it. So this one now will now go to, this one will now go to the input. This is the neutral. This is the positive line. Then this is the neutral. This is the negative line. Will come to the input. So by the time you do it, the charging cable of the inverter, will now be connected here like this. So this is the charging cord of the inverter coming from the inverter. So you can see the inverter stands as an automatic changeover uninterrupted power supply, which is UPS. Most of this inverter comes with UPS function. So the inverter stands as a changeover. When NEPA is over, the system automatically change to inverter and start supplying current to the necessary point. When there is NEPA again, the inverter automatically switch off and change to NEPA and still serve those particular points. So the inverter stands as a changeover in the whole system. So I hope you enjoy my YouTube. Please, you can subscribe, you can give me a like, and we are going to meet in the next video. Thank you. Bye.